And welcome back. We are going to go ahead and look at the multiple catch blocks. We have seen these before, but we're going to go ahead and hone in on a couple more fine details just to make sure that we have this concept really kind of under wraps. So the first thing is to kind of brush up on is when we talk about catching our exceptions. Now, as you recall, a try block can potentially throw any number of exception values, and they can be a different type. So you could have like an input mismatch, you could have a division by zero, etc. You could have just a regular exception. Now, in any one execution of a try block, at most one exception will be thrown. You can't throw multiple exceptions at the same time. You can have multiple exceptions handled, but the thing you have to remember is when you do a throw statement, that ends the execution of the try block. But since we have different types of execution values that can be thrown on different occasions when that try block is executed, each catch block, therefore, can only catch those values of the exception class type given in that catch block heading. So when you throw, for example, a input mismatch, it's only going to be handled by an input mismatch exception. Now, we can, of course, catch exception values of different types by placing one catch block after another for that try block. So, for example, like I said, you can have an input mismatch, you can have a division by zero, you could have just the regular exception class. Now, there is a pitfall to keep in mind here when we start looking at having multiple exceptions. We haven't really talked about this much, which is you want to make sure the order of those catch blocks is going to be important because you want to catch the most specific exception first. When we are catching multiple exceptions, the order of those catch blocks can be quite important. So when an exception is thrown in the try block, the catch blocks are examined in order, and the first one that matches the type of the exception thrown is going to be the one that is executed. Thus, the following ordering of catch blocks wouldn't be so good. So if I say like catch exception E, catch negative number exception E, you'll notice that exception E is the general exception class. And since that one comes first, it means it's going to do that exception first. And I'm not going to get that more specific information that I might have wanted from that second exception. So we have to use correct ordering here. With that ordering, the catch block for the negative number exception would never be used. Because, again, remember, all exceptions are caught by that first catch block, exception E, which is the general exception. It's going to take those in and handle it. Now, fortunately, if we try to do this, sometimes we'll get a warning that says, hey, did you mean to put the exception class first? It's always easy to remember, just always the general exception E class goes last. Now, if you have multiple things like input mismatch, you have division by zero, stuff like that, you may not get some of these warnings, so it's important that you know which way do you want this to be processed so you can handle it accordingly. So the correct ordering whenever you're dealing with multiple catches is to reverse your catch blocks so the more specific exception comes before its parent exception class, such as following. So negative number exception E followed by catch exception E. Because remember, negative number exception E is derived of exception E. And so again, you always want the one that's more specific, so you can think about which one is the one that's going to be the thing you need to catch first, that's going to give you that detail level. And if we come over here to this demo program, it's a real simple program. You see we're getting an input for the number of pencils, the number of erasers, and we're going to go ahead and catch this by a negative number exception and a division by zero exception. Now you notice that we don't have in here currently a catch for the general exception class. But if we go ahead and run this, how many pencils do we have? And we say if pencil is less than zero, so let's just go ahead and put in -1 here. And we say, hey, we cannot have a negative number of pencils. Perfect. So that is throwing this negative number exception, because if you look at the negative number, it says cannot have a negative number of e.getMessage, and of course we're packing in the word pencils. So let's go ahead and run this now. Let's go ahead and just put in a positive number. Let's just put in 3, and now we see how many erasers do we have. And so it says if erasers is less than 0, we're going to throw this one. If the number of erasers is not equal to 0, all right, so we got a not equals in here. So we're going to do an expression, and then of course we divide this out. So let's just go ahead and enter in this time 0, and we get do not make any mistakes, all right, because we're throwing this division by zero exception. And of course, if you look, it says right here, do not make any mistakes. So it doesn't necessarily mean that we have a bad thing, but it just means that we have no erasers. So if we go ahead and do this again, let's do 3, and this time let's do 3 erasers. It says each eraser must last through one 0.0 pencils. End of program. Now, if we wanted to have some other exception that could catch this, for example, let's say we wanted to catch just a general exception here. Now, we, of course, if we just do an exception E here at the end, and let's just go ahead and put that in. And we say something else happened. All right. Now, currently there's nothing to handle this, but what's if we did like an input mismatch here? So let's just go ahead and press the letter A, and we get something else happen, because even though this is technically an input mismatch, because we are catching it here with this exception, because remember, everything is encapsulated inside this giant try block, we get something else happened, and so that allows it to catch that. So having this catch-all can be very helpful. Notice we didn't need it for our program to run, assume we had valid inputs, but by having this here, it allowed us to handle it. Now, if I add in a input mismatch exception, it of course would then try to handle that based upon if I put an invalid input in. And of course, we could do things like try to get new input. We could, look at how the input could be sanitized. There's a whole bunch of different approaches that we can use to using this. However, of course, having these multiple catch blocks is really helpful, and you can see how it works really nicely. And you can see this singular try block, of course, you can see we threw for different exceptions here because this, of course, different part of the program. Now, if this program, let's say, was done with these exceptions, and then we had our program do something else down here, we had to maybe called a bunch of different methods and stuff like that, and then we'd say, hey, you know what, we want to get some fresh input. Then we would, of course, need to put in a new try block to be able to handle that set of code, and it would have to have its own set of catch blocks that would have to go with it. You wouldn't be able to come back and reference these existing catch blocks because these catch blocks, of course, are tied to this try block here.